So, Q2. Also, it was fun putting these slides together because you forget about all these things that you did and then you see them all again. But so this is what we set out to do 3 months ago. We wanted to pave the way for Monty to model compositional objects. We want to make Monty easy to use in a variety of applications, increase our academic engagement, and figure out how to model object behaviors. And so I'll just go through kind of the sub goals that we set for each of those. So for paving the way for Monty to model compositional objects, one of the sub goals was that the accuracy on unsupervised inference benchmark is dramatically improved via hypothesis resampling. And I would say that's definitely checked off because we went from 12% accuracy to 96 and from 6% to 94% accuracy. So I would say that's dramatically improved. And it's been done through hypothesis resampling. So great work, Rami. We had the speed of inference for distant agent dramatically improved via better policies. And this one has been deprioritized, which is why I made it gray, because there was a lot of other stuff that came up and we had to work on like finalizing the DMC paper and the hackathon wrap up. Or, well, it was a whole quarter, but yeah, generally the hackathon work as well took a lot of time, but so we deprioritized this one, but still towards the end of last month, Scott spent a lot of time on outlining how we want to do this, and we have a really concrete idea now of how we want to tackle that in the next quarter. Then putting together a test bed for compositional objects, so logos on cups is available, and that's done. Thanks to Scott's work last week. And then the performance baseline quantified is not done yet. That will be a bigger project, figuring out how we actually want to measure performance on that, how we want to learn, how we want to do inference and so on. And then also the motor system supports swapping out policies, which thanks to Tristan, it does now. Then on making Monty easy to use, we had the motor system is disentangled from other classes. That one Tristan did a whole bunch of work on, but it's a huge project, so it's still in progress, but there's been lots of progress made on it, as you can see from all these merged PRs. Monty is not constrained to Python 3.0. Again, it's in progress. There is a draft PR that Jeremy put here, and he put a lot of work into kind of making it unconstrained to Python, but we haven't merged it yet. And Jeremy's currently exploring a different path because with the newest Habitat Sim version, which is needed for a new Python version, that one for some reason requires GPUs. And then we have to add GPUs to all of our infrastructure just to run the simulator. And so right now, kind of the different path Jeremy is going down is adding a different simulator instead of keeping reliance on Habitat Sim. We published tutorials on using Monty in novel applications and in robotics. So I put up these 2 tutorials on that and then published several example projects. Those are the projects from the hackathon. So we have the Lego Raspberry Pi project and all its documentation. We have the ultrasound and all its documentation, and then also the drone project and kind of hints around what people should watch out for when building a robotics application, plus the website once it's public. Then, yeah, for increasing academic engagement, the kind of university outreach and creating content for targeting universities hasn't gotten as much attention as we planned this quarter, but still Will has created some of the content pieces, like a short form 2-page PDF, and then we'll also have the 2 papers to use once they are published. Everyone looked into conferences to go to, and I don't think all of them are booked yet, but at least everyone had looked into those. A lot of them are planned and booked. Yeah, some plans made for this year. And then adding 500 academic contacts on Twitter, Blue Sky. I think on Blue Sky we have more than 500 that we're following now. that will add it, and then on Twitter, not as many, but we kind of decided that Blue Sky works better and more academics are there nowadays anyways. So, but yeah, that's also still in progress. Will released 36 hours of video. Exactly. For some reason, YouTube doesn't give you this statistic. It just tells you how many hours people have spent watching your videos, which is 1,362 hours. But I went in with the calculator and just added them up real quick, and it actually added up to 36 hours. So I don't know if you planned this, Will, or if it just was a lucky coincidence, but
Just
um, but yeah, lots of research meetings that will processed and transcribed and uploaded.
and the most exciting thing is that we're almost caught up with the backlog of videos, so that's almost complete.
That is very exciting because we have like over 200 videos in that backlog, I think. And then yeah, the one that really got the most attention this quarter, I would say, especially from the research team, was publishing or finalizing these two articles, especially the DMC paper. And so yeah, Niels uploaded them last night to archive, and then yeah, for the peer-reviewed journal, that will take a couple more months to get the reviews and everything and address them. Then on the last one, figuring out how to model object behaviors, one of our goals was to have a concrete proposal for generalizing the stapler behavior to another object, including being able to predict observed features. And we do have a pretty concrete proposal for that, which is sending the kind of movement stored in the behavior model down to the child objects column and move through the child objects reference frame. And we also have kind of pretty concrete proposals for solving a lot of the questions around the modeling object behaviors. For a concrete proposal for how to model them in Monty, we do have some sections on that in the disclosure document that Jeff and I wrote and that we published, but not super concrete yet. So I put that to in progress. And then file provisional patent application or public disclosure. We decided to go with the public disclosure and disclose this PDF plus a bunch of videos of us discussing these new ideas. And so, although we didn't complete all of the sub things we set out for each of those, I decided to make all of these green because we did spend a significant amount of time on each of these items, on each of these kind of broad items, and made a lot of progress on each of them. And overall, pretty much almost all of the things we did fell into one of these four categories and these tasks we set out, which I thought was really great. So there was a lot of good focus on those. There were a couple of things that I didn't mention yet, but we still spent a good amount of time on. So I thought I'll put those on some slides to just highlight as well. One is interacting with the community, which is just kind of an ongoing effort, but still takes a lot of time from people in at least a lot of the instances when there are more detailed replies and questions. So yeah, thanks to everyone who interacted on Discourse and who posted replies to people's questions and helped them out there. And also for people who, like Tristan, who reviewed PRs on our Git repository from external contributors. Then also presented the project at several venues. So Tristan presented the project. Then I was on a podcast, and Scott also presented our project at the Chen Institute. And so both of those were two really nice new slide decks and new ways of presenting Monty. Really good to have in the repertoire. Got a better idea of potential applications of Monty. So Tristan visited some the expo and some other potential kind of place in the robotics space. I put together this presentation of applications and how they tie into the capabilities of Monty. And then Niels and I spent a fair amount of time talking to ultrasound, both ultrasound vendors and people who worked with AI on ultrasound and people who worked with computer vision and implemented kind of ultrasound projects and had access to clinics with ultrasound, just to kind of figure out what's out there in the space, and could this be a first application for Monty, and would someone be interested in building this? So that also got a fair amount of attention. And then the hackathon, although it was just 1 week itself, demanded a significant amount of preparation, both in terms of like ordering all the parts for it, pre-training models, and also getting like swag and prizes and stuff like that. And then also a significant amount of post work, like documenting everything. Tristan collected a bunch of feedback from everyone on like Monty's usability and issues they encountered, and started addressing some of that feedback, and then also some debugging work. And then there was also a good amount of brainstorming, especially also the brainstorming focus week. And I mean, I already mentioned in the main Q2 priorities that we do have a proposal for object behaviors applied on a stapler, but we also talked a lot about additional problems like object distortions. We talked about feature or surface models. We talked about generic and specific models. We talked about circles and ovals and interpolation and invariance and equivariance and learning in lower and higher regions and like all these different topics. So yeah, a lot of interesting ideas and thoughts. And then there were a bunch of code and infrastructure and style improvements that happened throughout the months, just kind of on a continual basis, improving things in little ways. So yeah, overall, really great job, everyone. I thought it was, yeah, really nice, all the things we accomplished. And then, yeah, now I would hand it over to Niels for a quick recap on everything that happened to produce the DMC paper.
Yeah, and I know there's been a lot of recap already, so I'll make it quick. But I just thought it would be nice, given that this was, a huge effort to get this out, to just kind of revisit, because yeah, it's definitely been a big milestone, and it's ended up being a big project that we worked on for a long time. But I think also everyone's really proud of what we put together, and kind of rightly so, because yeah, our ambitions kind of grew as this unfolded. And so the original kind of motivation was to essentially establish Monty's capabilities, show that to the community, and kind of communicate that to others, and kind of what the current state of the art of a 1,000-brain system is. And of course, there's a variety of reasons we'd want to do that, but amongst other things, one of the main kind of aims of the TBP is to get people excited about and using 1,000-brain systems in this approach. And so, of course, showing what it's actually capable of is a big part of that, especially the academic community. But kind of along the way, I think it was just surprising how many kind of new things that came out. So new metrics, new understandings of what Monty's kind of actually capable of, that we hadn't really conceptualized when we kind of first decided to write this. And also just lots of kind of fixes and general improvements to Monty's implementation, and many of those were definitely not trivial. And so it's been a huge team effort. Everyone at the 1,000 Brains project, and also, like I said on Wednesday, a lot of the groundwork for this even started at Numenta. As Viviane was saying, although we've been working on the DMC paper for maybe 8 months, really this started more than 3 years ago with the actual kind of initial work on the 1,000 on kind of Monty. But definitely special shout out to Scott and Hoj for the huge amount of effort they put into this. I think when you guys joined, the idea was this was going to be like a 2, maybe 3-month project that would be kind of a nice way of getting to familiar with Monty's experiments and how to run those and things like that. And so thank you for all the effort you put in. Despite it being actually a much bigger project we ended up doing. And so, yeah, kind of to rewind back to when we kind of started on this, what we had at the time was, of course, Monty, certainly a similar version to what we have now, but with some, as I said, kind of bugs and things like that we later discover. And we had some benchmarks kind of gauging approximately things like accuracy in the context of certain amounts of noise and things like that. And we had some kind of visualizations, but nothing particularly kind of glamorous. And so when we were kind of doing initial scoping work, I said it kind of started fairly simple, but then eventually grew quite a bit in ambition. And I'm not going to spend a long time on it, but just to kind of put into a bit of context, the amount of work that went into some of these figures, we had these Excali draw boards where this is just a version 3, where you can see there's a huge amount of variations and comments and all this kind of stuff going on. And this was version 4, and I think it went all the way up to version 5. But what we ended up with was these 6, I think, really beautiful results figures that do a really nice job of just showing how diverse Monty's capabilities are. And that's, I think what's so exciting about this is that any one of these would be an impressive result. But the fact that all of these capabilities kind of fall out almost automatically from developing sensory motor AI informed by the cortex is pretty exciting, and feels like a pretty strong kind of signal that what we're doing is on the right track. And along the way, this resulted in 2 new repositories, which are providing comprehensive kind of support for anyone who wants to replicate these experiments. That's really important from the point of view of open science, and it should also really build trust in what we've done and increase the likelihood that people kind of build off of this. But yeah, this was a huge amount of effort, when 30,000 lines of code and experiment configurations for the kind of main paper repository, and then this epic repository that Hojay put together, tpp.floppy, which for the first time enabled us to quantify the amount of flops that the amount of compute essentially that Monty consumes, and enable us to benchmark that against VITs. But this doesn't capture all this other stuff, as Viviane was highlighting before. Even just things like replicating the experiments, not to mention running them in the first place, and running them many times, I should say. Every time we'd realize some kind of change we should make to the figure, or some bug had been identified, or whatever it happened to be, that kind of led to a cascade of running all this again. So a huge amount of effort. And so, just a quick kind of summary of some things in terms of new evaluations and metrics and things like that. We added better visualizations of movement sequences. For the first time, we properly quantified symmetry and kind of found a way of verifying that. We looked at adversarial color robustness. We looked at the kind of stepwise effects of the model-based policy. Looked at scaling of voting for the first time and figured out tie breaking. Quantified learning efficiency and also versus VIT. We had no comparisons before at all to deep learning architectures, and that was a huge effort, particularly on Hojay's effort to get that. Also comparing flops and quantifying that versus a VIT, also looking at continual learning and comparing that against the VIT. Plus, outside of that stuff, we got updated professional diagrams. We did a literature review on related approaches. Had a whole bunch of improvements to the configs, just simple things like specifying a voting system in Monty where you have multiple learning modules in a grid was not trivial at all before. Scott made lots of nice improvements to that. We have now kind of a comprehensive mathematical description of how Monty works, which we didn't have at all before, and notation for that. And then fixed a whole bunch of bugs, which, yeah, I said none of these were trivial. Things like when we started this, voting only worked with learning modules and sensor modules basically aligned in a one-dimensional grid or kind of aligned. We couldn't have kind of other arrangements. Something with the X% threshold we fixed, patch off object. That was again a huge effort on Scott's part. And then kind of semantic sensor. This was a thing that was sort of leaking into our experiments that we didn't want to. So I'm sure I've missed some stuff. So it was a lot of things. And of course, I think all these metrics and evaluations that we've now developed and the pipeline for visualizing them all this stuff is work that we can reuse when Monty's capabilities grow, and we want to communicate that again. So it's definitely not kind of a one-off use case. And of course, now we have this 32-page paper that we can share with everyone and talk about when they ask, what can Monty actually do? So yeah, thanks everyone for their hard work. Yeah, kind of patience through this whole process.
Yeah, and I guess since you didn't highlight yourself, I just want to highlight that it would not have been this really high quality, awesome paper with all these great results if it wasn't for you. And like you put this huge amount of effort into it. And especially over the past months, really pulling everything together, coordinating everything, making sure all the experiments are up to high quality standards, writing really nice text that is like really fun to read. And yeah, up to last night, figuring out last issues, looking into last little numbers, whether they are actually correct. And yeah, it would not have been this great high quality paper if it wasn't for you.
Great work, Niels.
Everybody.
Thank you.
And
Yeah, I didn't know-
everybody.
Yeah,
Awesome.
definitely.
I didn't know what this paper was going to be like when you first started on, but it turned out much, much better than I imagined. And it's very great and creative and great results. So it's really, really impressive. Thank you.
Thank you. Yeah, thanks to everyone.
So Q3 has already started last week. And so Niels, Tristan, Will, and I kind of put together a couple of priorities again. Oh, I forgot to change this header. It should say 3 here, but I kind of liked how they aligned last time with our TBP mission, so I tried to align them again this time. And some of them are kind of similar to last or extensions of last quarter's priorities. So first one, this one is kind of an extension of first one from last month. Last month we were kind of lining things up for Monty to be able to model compositional objects. In this quarter, we really want to have Monty actually model compositional objects and assess its accuracy and demonstrate that with hierarchy we can model compositional objects in Monty accurately and efficiently. Then second, we want to make Monty easy to use, improve, and contribute to, both for the TBP team and for external people. And again, I'll break down each of those into like a couple of actionable items that we're planning to do for those. Third, we want to increase external interest and awareness of our approach. And fourth, figure out how to model object behaviors, finally, completely. And so what do those kind of concretely mean? Enabling Monty to model compositional objects accurately and efficiently. First of all, we want to set up a dataset, training, and inference protocol and evaluation measures to evaluate Monty's compositional modeling abilities. And that's not trivial. So we have this dataset that Scott put together, but now we need to figure out, how do we actually train Monty on that? How do we give a supervisory signal for like what's the child object, what's the parent object? How do we evaluate what's the correct classification, since different learning modules will have different objects that they recognize. And so we'll have to set up a couple of new evaluation measures and kind of think through how training and evaluation should look like in this compositional object setting. Then we want to improve hypothesis resampling based on different signals. So last quarter, Rami implemented this way to resample hypotheses. And then now we have a bunch of signals that we want to use to kind of inform that, such as prediction error, out of reference frame movement, salient features, and confidence. And that should manifest itself as improved or comparable accuracy on the compositional data set with reduced computational overhead. So kind of being faster and more accurate, because we don't have to test a whole bunch of hypotheses. And then saccade policies to improve accuracy and enable sparser models, which basically means we move more principled. Like right now, we kind of do a random walk on the object, but that kind of ties into these model-free policies to saccade to salient features, and or make sure to stay on an object until it is recognized. And then lastly, adding and testing this idea of a 2D surface sensor module that basically extracts 2D movements and features to learn things like the logo that's kind of a 2D representation that can wrap around 3D objects. Then on making Monty easy to use, improve, and contribute to, we have a continuation of the motor system refactor, so disentangling the motor system from other classes. We have Monty not being constrained to Python 3.8 anymore, which also ties into the support for Mojoko Simulator. Adding an interactive and up-to-date overview of where people can contribute, so that hopefully the amount of external people who contribute significantly increases even further, because we make it easier for them to see where they could contribute. And then also adding more documentation on how to do that and how to customize Monty for specific applications. Again, kind of making it as easy as possible for people who want to contribute or who want to use Monty to actually be able to do that. Increasing external interest and awareness. We have publishing material around the hierarchy and DMC paper. So Will has already a bunch of stuff lined up for that. And there's also more to put together. So videos, presentations, plain language explainers, posts, and so on. Presenting Monty and Southern Brains theory at several conferences and speaker series. Part of that is also kind of reaching out to some universities and presenting at their symposium, speaker series. Organizing an online workshop / symposium about Monty, again, kind of similar to what we did in December. And this might not actually happen in the next quarter, but to at least organize it and plan it. And then figuring out how to model object behaviors. Again, we made a lot of progress on that already in the past half year, but hoping that in the next 3 months, we can kind of have a theoretical proposal for all the open questions we currently still have around, especially object deformations, and hopefully also how actions kind of turn into that, kind of play into that, how actions change the state of objects. And then a concrete write-up or even a prototype of how object behaviors could be modeled in Monty. So actually, I'm kind of hoping actually a little code prototype of that, but it depends a bit on how complex that solution we come up with will be. And so yeah, that's the two parts here. And then again, there's a Google Doc in our Drive that I can also share in the team channel later that has more details. So those were just kind of the high-level company priorities, but there's also more detailed breakdown, especially of the research objectives that Niels can go over later in the research meeting. And also the engineering and community objectives are a bit more detailed, broken down there.